Today we are going to discuss the physical properties of non. Today we will be discussing the physical properties of non-metal. Now, properties means the basic characters of any substance. When we are talking about physical properties of non-metal, we'll be taking into account all the properties which are related to its physical nature. That is, you can say we will discuss about the melting point, boiling point, then we'll discuss about its state, in which state does it exist, and how does it look, how does it, what is its weight, and about all that, about its density and that. Okay, so basically we had studied in the last class about the physical properties of metals. We can say that the physical properties of non-metals are completely contrast to it, like because of their change in chemical behavior. Okay, so first we'll discuss the physical properties, and then we'll relate their differences in the chemical properties. Okay. We'll be discussing first physical property, that is the state of the non-metals. Actually, non-metals do not have a single state. They are found in three states. We can say non-metal exists in liquid, solid, and gases. All the three states are present for a non-metal. For example, we can take off a liquid non-metal, that is bromine. Bromine exists as a liquid at room temperature. This all states we are talking at room temperature. Okay. At room temperature, bromine exists as liquid. Okay, and solids I can say iodine, uh, carbon allotropes. These all exist in solid form. More you can see sulfur, it also is in solid form. So there are various non-metals which exist as solid form. Now some examples of gases if I want to take, then it is nitrogen, oxygen, chlorine, okay. All the rare gases you can talk about, argon, helium, neon. Okay. So there are some more gases which are in solid form, the non-metals. So this is about the state of the non-metals. So if it is asked to you the how many states you can see for a non-metal, then there are all the three. The next physical property that I am going to discuss is about its hardness. Actually, non-metals are not hard. You can see most of them are gases. So they are, and those which are even solid, they are brittle. They are very brittle. Means they break down easily on being banged. Okay. So they break down easily if just like a glass. Okay, when you just put the glass down, it breaks. Similarly, here you can see the non-metals. They are very brittle. They break very easily. The next property that we are going to discuss is about its ductility and malleability. Okay, malleable means I have discussed already. Malleable means in the form of thin sheets, and ductile means to draw thin wires. Okay, so non-metals are neither of them. Means they are neither malleable nor ductile. They cannot be drawn into mats, nor can be they drawn into thin wires. So we can say that non-metals are not malleable and not ductile. Carbon, basically you can say carbon wires are made nowadays, carbon filaments are there, but that is okay. Actually, generally the non-metals, they are not malleable and ductile. The next property that we are going to discuss is about the lustrosity, means whether the non-metals, they are lustrous or not. So I can say that non-metals are not lustrous, means they do not shine. Okay, they do not shine at all. See the air around us, there is nitrogen present, oxygen present, does it shine? No. So you can say that non-metals are mostly, they do not shine. Only here we can say iodine as an example and graphite as an example, which are lustrous. Graphite actually is lustrous due to the presence of electron in it, which is free to move and show its lustrous property. So most of the non-metals, they are not lustrous. Exception you can take here is diamond, exception is iodine and graphite. Both of them are lustrous, means they shine. Other non-metals, they do not shine. The next property is low melting point and boiling. The next property, that is, we're going to talk about the conductivity. Whether non-metals can conduct heat and electricity or not. So I can say that non-metals, they are bad conductors of heat and electricity. That is, they do not conduct. How would it happen if the non-metals like oxygen would conduct electricity? It would be really very amazing. But that's not possible. All the non-metals, I can say, they do not conduct electricity. Is it true? All the non-metals. Here again, I'll talk about an exception which you have to keep in mind. That is graphite. Okay, graphite is an exception. Graphite conducts electricity. It is able to conduct electricity. Actually, graphite structure is such that it is having a free electron, and due to the presence of this free electron, it can conduct electricity, and that is why also it's lustrous also. So I can say that graphite, due to the presence of free electron, it can conduct. Here I'll show a little arrangement of graphite layers, how graphite layers are arranged. Actually, graphite arrangement is such that there are hexagonal arrangement. Hexagonal layers are packed, and these layers, they make, in this way the graphite is arranged. Here again you can see that the layer is there, below it there are some, and it is very soft. Graphite is very soft, it can be cut with a knife also because of the arrangement of the graphite. The carbon atoms are bonded such that they can be cut easily. Here there is arrangement of carbon. Each carbon is bonded with three other carbon atoms. Okay. So here there is a free electron which moves, and which is the cause for the conduction of electricity. So graphite, due to its presence of free electron, it can conduct electricity. Hence I can say that an allotrope of carbon, that is graphite, has the ability to conduct electricity. Now the next property about its hardness. Non-metals are brittle, as I have said. About the hardness, when I talk, it means those non-metals which exist in solid form are generally soft. For example, I have talked about graphite. It can be cut easily with knife. The iodine, they all are soft. But again, here one exception in the case of hardness, that is about diamond. Actually, diamond, it is arranged in such, the carbon atoms are arranged in such a manner that it provides it a lot of strength. The carbon carbon bond are very strong in it. Okay, and due to this strong carbon carbon bond, the diamond, it has a great strength, and therefore it is very hard. It is very difficult for us to cut a diamond. A diamond is only used for cutting diamonds, right? So due to its hardness, it cannot be, the glass etc., they are cut with the diamond needle, like if it, because they are very hard, they cannot be cut easily. Okay, so diamond is very hard, or I can say the hardest natural substance. Okay, other non-metals are soft and they can be cut easily, those which are soft. Bond, carbon carbon bond is very strong. If I want to see the how the carbons are arranged in a graphite, you can say they are tetrahedrally arranged. Means each carbon atom is attached with four carbon, and then they again, so they form a tetrahedral structure, I can say they form a tetrahedral structure. And due to this arrangement, the next property which we are going to discuss is the boiling point and melting point. Non-metals, they have very low boiling and melting point. They have very low melting and boiling point. It means they melt at very low temperature and they boil at very low temperature. For example, you can see the most of the gases, the existing gases form at the room temperature. It means their boiling point is well below room temperature, so they are having very low boiling point. When I talk about melting point, most of them they have very low melting point. Here again, the exception I talk is about graphite, which is the allotrope of carbon. Graphite has high melting point and boiling point. It has about 3730 degrees Celsius. Such a high melting point. Okay. So you can see that all the metals and non-metals, they are having different physical properties. They have contrast physical and chemical properties. Talking about boiling and melting point, we can see graphite, due to its stability of its arrangement of the carbon atom, it has such a high boiling point. Means the carbon-carbon bond are very strong, and that is why they are having very high melting point. So I can say that the non-metals generally have low boiling and sonorosity. Means whether they are sonorous, that is produce sound. This property is not present in non-metals. Means non-metals are not sonorous. They do not produce sound when they are hit. If I hit in air, there is no sound. So sound is not produced when non-metals are hit. Suppose I am hitting in air. Does there any you can hear any voice, any sound is there? So you can see easily that non-metals, they do not produce sound when they are hit. The next property, that is density. Non-metals, they have very low density. Their density is very low. Again here exception is there. That is those which have the state is solid. For example, I can talk about iodine. Iodine is an exception. It is having high density. So this is about the physical properties of non.